Okay, so today we're going to talk about compositions of reflections as well as compositions of other transformations being put together and what types of movements they create and what types of figures they create. So the first thing I want to talk about is congruent figures and what that means and what that looks like on the coordinate plane. And so two figures are congruent if and only if there's a rigid motion or a composition of rigid motions, R-I-G, that maps one figure onto the other. So remember, rigid motion doesn't change the size or shape, and so that's translations, rotations, reflections, everything we've actually talked about in practice with. Dilations are non-rigid motions, and those are the only ones that will create figures that are not congruent. And we will talk about dilations more next time. A congruence transformation is another name for a rigid motion or a combination of them where the image and the pre-image are congruent. So that just means that we're not changing the size or shape. We can combine as many motions as we want, but we're not changing the size or the shape. Okay, so when we compose and put together reflections, they create some interesting movements. And so the first one is a translation or a rotation is a composition of two reflections. So we can create a translation and we can any translation and we can create any rotation with two reflections. Okay, so if we have two reflections that are a parallel line, that creates a translation. So if we reflect this R right here over this line L, and then we get this one, and then we reflect it over M, which is parallel to L, we get this R here, which is just like a translation of the original R. So it's a slide of that original R. And you can see that it's even oriented the right way. We haven't rotated it at all. If we reflect over two parallel lines, the only motion that's created there is a translation. If you have lines that are intersecting, so basically any that aren't parallel, it creates a rotation. Okay, so when we have this R here and we're reflecting it over two lines that intersect, so over line A and then again over line B, it creates a rotation. So if you notice the point of intersection here, this part of R is the same distance away from that point of intersection after those two reflections that create that rotation. Okay, so it's either parallel and creates a translation, or if they're intersecting, which is everything that's not parallel, then it creates a rotation. Okay, a glide reflection is a translation and a reflection across a line parallel to the direction of translation. So what that means is this line is the direction of translation and the line of reflection is here, which is parallel to these two lines are parallel. And so when we glide down and then reflect over a line that is parallel, it doesn't have to be right next to the figure, but it does have to be parallel. And that's what we call a glide reflection. It has a specific name. Okay, so try to take a look at these and describe the isometries, again, which just means they're congruent to the original. And so we're looking at this original one to start each time. And there's translation, rotation, glide reflection, or just a reflection. And so think about what each of these are. Okay, this first one is a rotation of the original. And the second one, you can see it's oriented the same way, so that's a translation. I struggle with this one because it's actually kind of a glide reflection because it's been translated down and reflected. So I would say glide reflection or reflection would be acceptable for this one. And then this one is a glide reflection because it's translated this way and then reflected over the line that's parallel, so one that's parallel to this, to go here. So this one has to be a glide reflection. I would say this one I would call a reflection, but if you want to call it a glide reflection because it's been translated and then reflected that way, that would be acceptable too. Okay, so now we have this triangle TEX, and we want to do a glide reflection where the translation is +1 in the x direction, and then the reflection line is y equals -2 because that's going to be a line that is parallel to that direction of translation. So we're going to take all of these and move them, all these vertices. So again, you want to pay attention to vertices when you're doing a transformation of any kind on the coordinate plane. So this would be t prime, e prime, and x prime. Then we're going to reflect that line, or reflect over this line, x, which is y equals -2 because it crosses the y-axis at -2. So 1, 2, 3, it's 1, 2, 3 away, this x prime, so x double prime will be 1, 2, 3 away. And this will throw people, but 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and we're just going to put it right there. Yes, I know it's off the graph. And then we're going to do this one here, so we're 1, 2, 3, 4 away, and 1, 2, 3, 4 away. So this would be t double prime. So our final triangle would be right here, which is t double prime, e double prime, x double prime. And that's a glide reflection. Let's try a couple more here. So we're going to do some more glide reflections. And so we'll do our translation first and then a reflection. And so what I would say is at this point, if you want to pause this video, try these on your own, and then unpause and listen to me go through it. That might be a good idea just to make sure that you can do these glide reflections. So again, I'm going to give you a chance to pause it before I start going through it. Okay, so this first one we're going to go +2 in the x direction, so I'm going to move all of the vertices over 2 to the right in the x direction. Then our reflection line is going to be y equals 3, which is this line here. And so again, it's going to go off the graph way up here. And then this one is going to go way up here. But it should be something like that. Okay. We can also do a translation in the y direction. So we're going to move everything down 3 spaces and then reflect over a line that is x equals. Okay, so now we have our new triangle, our intermediate triangles. So that's the translation, and now we need to do the reflection. So where x equals 0, this gets a little confusing. So if you go to the x-axis where x equals 0 is here, and it's this vertical line, so it's actually the y-axis that we're reflecting over. And so some of these points, like this b prime, is going to reflect this direction. So we're going to get b double prime. And some of them, we're going to go the other direction. But what's important to remember when you do reflection is that it's the same distance from the line of reflection. So this is 2 away, and so we go 2 in the other direction. Okay, and just like this b, it was 1 away, so we went 1 in the other direction. So now I can copy down, or connect those points to get my final triangle after the glide reflection. Okay? Alright, please let me know if you have questions, otherwise you can work on your Big Ideas 4.4 assignment.